Now let's see an example on Banker's algorithm, that is deadlock avoidance algorithm. Okay. So the question will be given like this. Consider a following snapshot of a system. They will give you some processes, the number of processes. Here the number of processes are 5, P0, P1, P2, P3, P4. Okay, P0 to P4. And they will give you some allocation matrix and max matrix and available matrix. Okay. So here available is a vector that consisting of only one row and three columns. Okay. Max matrix, this will be your 5 rows and 3 columns, and allocation matrix it will be 5 rows and 3 columns. So number of rows are depends upon processes, number of columns are depends upon the number of resources. Okay. So Banker's algorithm is suitable for resources with multiple instances. Okay, with multiple instances. Okay. So here they may ask the questions like, this is a previous year question, how many resource types A, B, C are there? So we need to find a total matrix here. Okay, how many resource types of A, B, C are there? We need to find a total matrix. Okay. Second, what are the contents of need matrix? We need to find a need matrix. Then, is the system is safe? Here we will use safety matrix, safety algorithm. Okay, to decide whether the system is safe or not. Okay. Then if a request from process P1 arrives the additional resources of 102, can the Banker's algorithm grant the request immediately, show the new system state and other criteria? So here we need to apply the resource allocation algorithm. Okay. So first we need to find the total matrix. How to find the total matrix? Okay. So the total matrix is the total number of resources available currently. Okay, that is 3, 3, 2 plus how many resources that we are allocated until now. That is number of A resources. If you look at the column of A in allocation matrix, we need to go for allocation matrix. It is 2 plus 3, 5 plus 2, 7. So 7 plus 3, total 10. Okay. Then 1 plus 1, 2. So 5. Then 2 plus 1, 3 plus 2, 5. So total 7. The total matrix, that is total number of resources available, are 10, 5, 7. That is 10 A resources, 5 B resource and 7 C resources. Okay, 10, 5, 7. So 10 A instances, 5 B instances, C 7 instances. That is the answer for first one. So we need to find a need matrix. Okay, what is mean by that? The need mat, how to calculate need matrix? We need to subtract max matrix minus allocation matrix. Okay, max minus allocation matrix, so that we can find need matrix. Okay, so max of n cross m we need to find by subtracting max of n cross m from allocation of n cross m. Let's see this one. Okay, so here we can find it, then max matrix. Okay, so how to find the max matrix? This will be your max matrix. It is 5 by 3, that is total number of process n, total number of resources m. So this is allocation matrix, again 5 by 3. So we can find need matrix of 5 by 3. Okay, so how? 7 minus 0, 7, 5 minus 1, 4, 3 minus 0, 3. Okay, similarly 3 minus 2, 1, 2 minus 0, 2, 2 minus 0, 2. Okay, so 9 minus 3, 6, 0 minus 0, 3, 0, and 2 minus 2, 0. Similarly 2 2 2 minus 2 1 1, we will get 0 1 1. Similarly 4 3 3 minus 0 0 2, you will get 4 3 and 1. Okay, so this is our need matrix. This need matrix and allocation matrix we need in in safety algorithm. To find the safety of a state, current state, we need to use both need and as well as allocation. Okay, so I'm writing allocation matrix here and need matrix here. Okay, now let's go to safety algorithm. Let's go to safety algorithm. The first step of safety algorithm is initializing the values of work as well as finish. Okay, so how to initialize work? Work is equals to currently available resources. See, here we are not giving the resources physically. Okay, so we are assuming that if we give the resources, all the resources to the processes, what happens, whether the system will go to deadlock or not. Okay, if the system is safe, that is no deadlock, then we'll try to grant the request. Okay, so let's see. Work equal to available. So what is the currently available resources that we have left? That is 3, 3, 2. Okay, so 3 A resources, 3 B resources, and 2 C resources. So I'm storing it in work so that I'm not disturbing this particular currently available. Okay, so what is the second step? I need to set all finish of 5. So here I means 5 equal to false. Okay, so I'll take 1, 2, 3, 4, 5. So P0, P1, P2, P3, P4. Okay, then I'm going to step 2. Now here I will go to step 2. Step 2, I need to check two conditions. Okay, for first I will take P0. For P0, starting from P0, I need to check the condition that whether finish of, first condition is finish of 0 equal to false or not. We will only consider false. Okay, finish of I equal to false. Is it true? Yes. So we'll go to next condition, that is need of 0 less than or equal to work. Okay, so what is need of 0? Need of 0 is 7, 4, 3. Okay, so I will write 7, 4, 3 less than or equal to what is the currently available? 3, 3, 2. Okay, so 7 not less than or equal to 3, 4 not less than or equal to 3, 3 less than not less than or equal to 2. So you need to compare like this ones: 7 to 4, 4 to 3, and 3 to 2. A, B, C. Okay, A, B, C. But even one condition is not satisfied, we are not allocating the resources. We are not going to step 3. Okay, so here it is not finished. So I am going to next one, that is for P1. Okay, so for P1 I am checking finish of 1 equal to false. Yes, it is false, right? It is false. Now what I am doing, now I need to check for need of 0 less than or equal to work. Okay, now let's see what is need value here for P1. 1, 2, 2 less than or equal to what are the current resources available? 3, 3, 2. Okay, now check 1 less than or equal to 2. Yes. 2 less than or equal to 3. Yes. 2 less than or equal to 2. Yes. So all the resources that are needed by P1 can be granted by using currently available resources. So we need to go to step 3. We need to go to step 3, that is work is equals to work is equals to work plus available of 1. Okay, now look at here. P1 maximum needs are 3, 2, 2, right? So currently allocated is 2, 0, 0, and it needs 1, 2, 2. So it needs 2, 3, 2, 2. All are allocated, and we need to take back whatever the allocated resources to uh, P1. Okay, so now what we have to do? We need to write what? Oh, sorry, this is available allocation. So this is work plus allocation. What are the previously allocated resources? We need to take it. So what is the current work? 3, 3, 2 plus currently allocated resources are 2, 0, 0. Okay, so 2, 0, 0. So what is the new work? New work will be 2 plus 3, 5, and 3 plus 0, 3, and 2 plus 2, 2. So currently available. Now the work will be changed. Work equal to 5, 3, 2, and we need to set finish of 1 equal to true. We need to set finish of 1 equal to true. So this will not consider for next time. Okay, now we have finished this one. So first process that makes a request is P1, that is finished with this particular currently available resources is P1. So we'll go to next P0 P1. P0 is not finished but P1 is finished. Let's see for P2. Okay, so if you take P2, for P2 again we need to check finish of 2 equal to false. Yes, finish of 2 equal to false. The condition is true. Then again we need to check for condition, that is step 2. What is that? Sorry, and we need to check for need of 2 less than or equal to work or not. Okay, need of 2 less than or equal to work. So what is need of 2? Look at here, need of 2 6 0 0. If you take this one 6 0 0 less than or equal to, what are the currently available resources? 5 3 2. Okay, so let's write 5 3 2. Now check the condition whether it's true or not. See, 6 not less than or equals to 5, then we are not considering this one. Okay, we won't go to step 3. So this P2 is not finished, so let's take for P3. For check for P3. P3 again I'm looking at it, finish of 3 equal to false. Yes, the condition is true. Finish of 3 equal to false, right? Equal to false. Yes, so what we have to do, we need to check for the need matrix whether need of 3 less than or equals to work. Okay, work vector. What is need of 3? 0 0 1 0, sorry, 0 1 1 less than or equals to 5 3 2. Is it possible to allocate the resources, all the resources needed here? Now let's check. 0 less than 5, yes. 1 less than 3, yes. 1 less than 2, yes. So we'll go to step number 3. What is step number 3? Work is equals to work plus allocation of 3. Work plus allocation of 3. So what is work? 5 3 2 plus, what is the allocation vector of 3? 3 0 2. Previously allocated is 3 0 2. So what is the new current work matrix? It will be, sorry, P3, sorry, that is 2 1 1, sorry. So it is 2 1 1. So 5 plus 2 7, 3 plus 1 4, and 2 plus 1 3. So currently new work matrix is 7 4 3. Okay, now let's check for P4, the last process in the first round. Okay, so P4, we need to change this particular P3 to false to true. Okay, let's check for P4 whether it's finish off. First condition is finish off 4 equal to false. Yes, 4 equal to false. Now check for min need. Is need of 4 less than or equals to work? What is the need of 4? Need of 4 is 4 3 1. Write down 4 3 1 less than or equals to work. What is work? Current work is 7 4 3. Okay, so is 4 less than or equal to 7? Yes. 3 less than or equal to 4? Yes. 1 less than or equal to 3? Yes. So let's go to step number 3, that is work is equals to work plus allocation of 4. Okay, allocation of 4. So what do you get? What is work? 7 4 3 plus allocation of 4 0 0 2. You'll get 0 0 2. So what is the new work matrix? Let's take new work matrix. You'll get 7 plus 0 7, right? So 7 plus 0 7, 4 plus 0 4, 3 plus 2 5. So new work matrix is 7 4 5. Okay, but and we need to change finish of 4 equal to true. Okay, so now come here and change finish of 4 equal to true. Okay, finish of 4 equal to true. So in the first round we have finished 1 3 4, and how many left? 2 left, 0 and 2. In the second round, if we finish 0 and true, okay, then the system is in safe state. Let's see how it will be done. Okay, now let's again check for P0. Okay, in the second round, now it is round 2. Okay, now check for P0. Okay, so what is P0? First we need to check uh, finish of 0. Okay, we are looking at finish of 0 equal to false in round 2. Okay, yes, it is done. Then what we have to do next? Finish of 0 equal to 2. Then we need to check for need matrix. Okay, so let's see need of 0 less than or equal to work. So what is the current work? Need will be 0743. Okay, so it is 743. What is the currently work that is left? 75745, right? So it is need of 0 and work is 7. What is work? 745. Okay, so it is 745. Now check 7 less than or equals to 7. Yes. 4 less than or equal to 4. Yes. 3 less than or equals to 3. 5. Yes. Okay, now we can add, we can go to next step, that is work is equals to work plus allocation of 0. Work plus allocation of 0. So what is work? Work is equals to currently 745, right? So it is 745 plus what is the allocation? 200. Allocation will be, sorry, P0 0 1 0. So it is 0 1 0. So current work matrix is 7 5 and 5, right? 7 5 5. This is current work matrix, and we need to set finish of 0 equal to true. Okay, so we will set finish of 0 equal to true. Then the only thing that is left is P2. Okay, if P2 is executed here, that is true, converted to true, then the system is in safe state. Otherwise the system is in deadlock, because if we go to round 3, there is only one process left for finishing. So let's see for P1. So, P2. Okay, let's see for P2 and check for finish of 0, because I am skipping P1 because finish of uh, 1 equal to true, that is not false. Okay, equal to false, the condition is true. That's why we are going for checking need of 2 less than or equal to work or not. Okay, so what is need of 2? Need of 2 is sorry, 3600. It is 600 less than or equal to work 755, right? So 6 less than or equal to 5 and 0 less than 5, 0 less than or equal to 5. So it is satisfied. Then we go to next step, that is work is equals to work plus allocation of 2. Work plus allocation of 2. Okay, so what is the work? 755 plus allocation of 2 will be 302. So what is the current work? After adding this one, it will be 10 5 5 plus 2 7. Okay, now finish of 2 is equals to true. Now all have been finished. All the 5 processes completed its execution with the currently available resources with the sequence. Okay, with the safe sequence. What is the safe sequence? First P1 completed, second P3 completed, third one P4 completed, fourth one P0 completed, at last P2 completed with the currently available resource. So this sequence is called safe sequence. This sequence is called safe sequence. That means if the system asks for P1, okay, system grants the request requested by P1, system can grant it up to all the resources that is asked by P1 can grant it, then followed by P3 P4 P0 P2. We get this particular sequence. Okay, now we can say that all the processes are completed and the total number of resources is equals to the work. Finally 10 5 7, and this is equals to total number of resources 10 5 7. This is equals to total number of resources 10 5 7. Okay, so we can allocate the resources, we can allocate the resources. So how to, okay, now, sorry, resource request algorithm. So now look at here, in the resource request algorithm, which one is asking for requesting? P1. Okay, so the P1 is asking for request. P1 requests the resources as the vector 1 0 2. Okay, 1 0 2. Now we need to check whether this is satisfies some conditions or not. Okay, so if we take this particular 102 as a request vector, okay, as a request vector, what is request vector? 1 0 2. What is the request vector? 1 0 2. Okay, so what is the need of this particular thing? P1, need of P1 is, what is need of P1 initially? Need of P1 is 1 2 2. Okay, so now let's check. 102 less than or equals to 1 2 2. Is the condition satisfied? 1 less than or equal to 1, satisfied. 0 less than or equal to 2, satisfied. 2 less than or equal to 2, satisfied. So first condition is satisfied. Okay, now check for second condition. 1 0 2 to the available list of available resources 3 3 2. List of available resources 3 3 2. Now this condition is also satisfied. 1 less than or equal to 3, 0 less than or equal to 3, 2 less than or equal to 2. So first condition is satisfied. That means the requested is less than or equal to need. Okay, it is not exceeding the need. Okay, it is not exceeding maximum resource available. Then whatever the request resources, it is currently available, so we can allocate the resources. Okay, so let's take available. Now we need to change after allocating. We are assuming that we are allocating these particular request resources. Okay, if you allocate the requested resources, then what will be the value? Okay, so what are the matrices that will make the changes will be happen? First, available, right? If you allocate the resources from 332 to 102, so it will become 332 minus 102. You will get 3 minus 1, 2. Only 2 resources left, and 3 resources of B and 0 resources of C are left. Okay, it will be 230. The new available is 230. Let's take new allocation 1 matrix. Okay, so it is allocation 1 minus request of 1. What is allocation of 1 here? Previously 200. Okay, so it will be 200 minus request of 1. What is request of, sorry, plus, because we are granting those requests. So 200 plus what is the request? 1 0 2. Okay, so what? 2 plus 1 3. 3 A resources are there currently. 2 0 plus 0 0, 0 plus 2 2. Okay, so this is new allocation 1. Okay, we need to make changes in the matrix. Then need of 1. Okay, so what is the need of 1? Let's check need of 1. Need of 1 is 1 2 2. Okay, so we need to make changes in the need of 1 because already requested resources are granted, so we need to remove. So 1 2 2 minus 1 0 2. So how many resources still needed by process P1? It is 1 minus 1 0, 2 minus 0 2, 2 minus 2 0. Still it needs 2 resources of B to finish its execution. Okay, right? So these 3 values we need to change. So currently available resources, it is 230. Then we need to make changes in allocation. So allocation will be 302. So in place of this one, we need to change 302. Okay, then still it needs 0 to 0. Okay, still it needs 0 to 0, that is 2 B resources, so that it can finish its execution. Okay, so this is what bankers algorithm. Okay, and still we need to check this particular state for whether it's safe state or not. Okay, so if we check this one and find the system is safe, then we can grant the request. Otherwise we need to wait for it. Okay, here we can grant the request immediately, okay, because the system is in safe state.